All right. How do we go about doing it? What was the chain rule? Okay, so yeah, we can change this slightly so we can see a little better. Okay. So how do we do the chain rule? Yeah. Yep. We can do that. So we got is x to the 1/2, and g of x is x squared plus 25. Okay. So the chain rule says we do the derivative of the inside function times the derivative of the outside, assuming the function's complete. So what's the derivative of x squared plus 25? 2x. What's the derivative of this x to the 1/2? Yeah. 1/2 square root of, and it's that function, so it's x squared plus 25. The square root derivative is one that comes up really often, so that's one of those ones you probably want to remember just because it does come up so often. So y prime is 2x, or sorry, not 2x, x over the square root of x squared plus 25. All right. Anybody know what the square root of x squared plus 25 looks like as a graph? What about x squared plus y squared equals 25? That is a circle. So if I took this and solved it for y, plus or minus the square root of x squared plus 25, it gives you a circle. So far, all the functions that we've looked at have been solved for a letter. Y equals, f of x equals, g of m equals, whatever it happens to be. They were all solved for that and set in terms of a single variable. So the question is how would I find the derivative of x squared plus y squared equals 25? I could do what I just did, solved it for y. That one does work out that way. However, then you really have to find the derivative of two equations. Because when I solve it, I have plus or minus the square root of x squared plus 25. So the one you just did was just the top half of the circle. We'd also have the bottom half of the circle. So some of the equations we can solve and still do. What happens if I have an equation like that? You're not going to be able to solve it for y. But we'd still want to be able to find the derivative of problems like that. We still want to be able to find the slope at any given point. Okay? So there's got to be a way or a method for us to do that. And the method is known as implicit differentiation. I think I spelled it right. I really am bad at spelling. Let's see. Oh, I didn't switch back over. Good. Then you don't see my spelling error. And my spelling error doesn't exist. Now you can see the proper spelling that in the fake one never existed. All right. Oops, sorry. So implicit differentiation allows us to take the derivative of things that we cannot solve for y, or like the graph I just showed you isn't a function at all. So when we looked at this graph here, that's not a function. That fails the function test. Like it fails the vertical line test. Okay. However, depending on what you're looking at, that could be the path of an object. That could be a boundary in a video game. There could be lots of things that could be modeled like that. Everything doesn't have to necessarily be a function. Okay. And the more complex you look at things, the more complex the equations get for it. So, but it still has a slope somewhere, and we have to be able to find it. All right, so let's look at this problem. We've already done it, in essence, once. You solved it at the very beginning. But let's look at it in terms of using implicit differentiation. So you remember that the term d dx, the d over dx, that's derivative. So we're going to if I have addition, can I split that up in terms of derivatives? Yes, I can do the derivative of each piece. So I have d dx of x squared plus d dx of y squared equals d dx of 25. All right, so what's the derivative of x squared? 2x. What's the derivative of 25? 0. So y is a function, okay? So when we're looking at doing the derivative of y, we have to do it as a chain rule. All right. So what's the derivative of y squared? If it was just y squared, that'd be 2y. But I have to multiply it by dy dx. I have to multiply it by the derivative of whatever that is. So whenever you take the derivative of the y, you're multiplying it by its derivative, which is the dy dx, which we've seen before. That's when we were looking at that y prime could also be shown as dy dx. And remember, that was another way that we could write the derivative of y. So in essence, you're doing the derivative as normal. You just have to multiply your y. Anytime you do it as a y, you have to multiply it by dy dx. Now we have to solve for dy dx. We want to get this piece here by itself. Okay, so how would I solve that? No, not going to multiply it. I was trying to figure out what you were thinking. And then, no. If I got to solve, if this was just a B or a letter, how would I solve this using the simple algebra? How would I actually go through and solve the equation? Yeah. Exactly. Let's move the 2x over. Did I put a negative sign in front of that one? I did not. That was a negative. I knew I missed something. That's okay. So I have 2y dy dx equals negative 2x. And then divide by the 2y. So dy dx equals negative x over y. What did we say y was before? If we were in this problem, we were able to actually solve for y. What did we say the y was? Right? It was plus or minus the square root of x squared plus 25. So if I plug that in, I get negative x over plus or minus the square root of x squared plus 25. Wasn't that what we got at the very first problem? Except for the fact that I forgot the negative sign. That was exactly what we got. So this in the original problem gives me the exact same answer. Okay. We don't have to solve for y though. We don't have to do all that extra work at the beginning. We can do the derivatives in terms of the x and the y. So it saves me some steps there and allows us to do more complex problems that I couldn't actually solve for y like I was able to do this one. Okay. Does that make sense? Now I get more complicated. We'll do some more problems. It's not a big deal. But I want to do one extra step with this one. So one of the things that whenever you're doing derivatives, we can do is we can find tangent lines, okay? Or we can find the slopes of lines. So in this problem, I've got dy dx is negative x over y. That's what we just found. They want to know the equation of a tangent line at 0.34. Okay. So if we look at our graph, for this, they want to know what the slope is and then what the tangent line is at that point. So we've got our equation. We've got our equation for our slope. That's what our derivative is going to give us. All we do is plug in the point that they gave us. So they gave us 0.34, right? So what's x? What's x in the point? 3. So negative 3. What's y? 4. So that's my slope at 0.34. That's my slope. Or m. Yeah.
Wait, so you can automatically assume that dy over dx always be minus x over y?
No, for this problem. But we just found that. That's what we just found here. So we found the derivative. We did the derivative. We found out that the derivative of this one is negative x over y. The other problem that I had, remember, I had y prime was, what was it, negative x over the square root of x squared plus 25. If we plug this in, negative 3 over the square root of 3 squared plus 25. Oh, you know what? Hold on a second. It wasn't plus 25. It was minus 25. I did totally screw that up, but that's fine. That's better. Comes out to be the same thing. This one's just easier to work with. All right. How do I find my equation of a tangent line? Well, I have my m. That's my slope. How do I find the equation of a line? Yeah. Or you can use, since we have a point, you can use the point slope formula. The y minus y1 equals m times x minus x1. You can do that too. So y minus 4 equals negative 3/4 x minus 3. So we can distribute negative 9/4. So y minus 4 equals negative 3/4 x plus 9/4. So y equals negative 3/4 x plus 25/4. Yeah, I did that part right. And if we look at the graph of that one, it is my tangent line at that point for the slope, for the circle. Yes. Yeah. Yeah. The next couple of problems we're not going to be able to. This one we could. I started off with one that we actually could do, so you can see the connections between them. All right, let's look at this one. This is what the graph looks like. Okay. So this is a named one. It's known as the folium of Descartes. He decided to name it after he drew it. So if we look at this equation, we have x to the third plus y to the third equals 6xy. We could not solve this for y. Okay. So this is one of those ones where you have to use implicit differentiation to do it. All right, so let's find our y prime of this. So what's the derivative of x to the third? 3x squared. What's the derivative of y to the third? What was it? You're missing one piece.
Oh, yeah.
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 So we have 3y squared. You can write this as one of two ways. So you can write it as dy dx, or you can write it as y prime. They both mean the exact same thing. Okay. Sometimes it's easier to do one, sometimes it's easier to do the other one. Let's make a difference. What's the derivative of 6xy? Now, did I do it right? Is 6x or 6y prime the correct answer? What's 6xy?
Oh, because you got to do the y. Yeah, you're right. 6 times x times y.
So we have to do what? We have to do the product rule. No. We have to do the product rule for 6xy. I know. So 6xy is a product. And the x to the third plus y to the third, we could split that up because it's addition. And in derivatives, we could split up addition, do the derivative of each piece. That's fine. That was the first thing we looked at when we did the power rule stuff. But you cannot do that to multiplication and division. So we have to look at this in terms of a product rule. So we're going to look at 6x and y. All right. So what's the derivative of 6x? 6. What's the derivative of y? That's y prime. So what's the product rule? It's the derivative of the first times the second, right? So 6y plus the derivative of the second times the first. So 6x y prime. So all the rules that we learned so far, still have to use them. Still have to use the product rule. Still have to use the quotient rule. We're in essence doing the chain rule by doing the implicit differentiation. All right, are we good to that point? So the next thing we have to do is you want to solve for y prime. So how do you want to go about getting that together? We want to get that by itself. Sure. Okay. Now what am I doing? This keeps going back to the whole concept I told you that algebra is going to be your downfall. Yeah. I could. However, I still have a y prime on this side. No. Because I'm going to end up, if I divided both sides by y prime, I'm going to have y prime under here. Right. But if I divide this side, I have to divide this side. And I cannot cancel those because there's addition. I can't cancel through addition.
Can we move the 3y squared y
Over to the other side? Yeah, let's try that. Let's do that.
factor out?
Now, okay, I'll pull that out. Now we can divide. I'm going to divide by the 6x minus 3y squared. So y prime equals 3x squared minus 6y over 6x minus 3y squared, which technically I could pull out a 3 out of the whole problem and get x squared minus 2y over 2x minus y squared. That's going to come up, this type of problem, a lot, where you're going to have multiple y primes and you're going to have to do something. The goal is get all of them to one side, and then you can factor that piece out. Okay? That is something that comes up quite often. All right. So this problem had a couple other parts to it. While you're finishing writing that down, I'm going to write something real quick. So you can see why in this problem I did not use the dy dx. Because while you could have and it wouldn't have changed the problem, it's just a little more confusing when you're trying to move things around, divide, and everything else. The y prime made it a little bit cleaner to use. So, all right, so we've got that. The second part of this question said find the tangent line at 0.33. So how do I find my tangent lines? That's going to give me my what? That'll give me my slope. So yep, let's plug in 3,3 to this point. So y prime, or I'll just do m. So 3 squared minus 2 times 3 over 2 times 3 minus 3 squared. So 9 minus 6 is 3. 6 minus 9 is negative 3, so negative 1.
Yeah.
Yep.
But it's saying why you put the 3 that's in the y spot.
Yeah.
Okay.
Yep. Yeah, you're using the x and the y. And this one, they happen to be the same number. The last one they weren't, was a 3 and a 4, which made it a little bit easier. But yeah, and this one, they're the same plan. So then so y minus 3 equals -1 times x minus 3. So y equals -x plus 6. That's my tangent line. Yeah, that one worked out nice. All right. The next question says, at which point in the first quadrant is the tangent line horizontal? So if we looked at the graph, we're looking for a line that's going to be horizontal. So somewhere right around there, right? It's a little off, but so somewhere right around there. That'd be horizontal, right? Okay. How do you think we'd go about doing it? Okay, let's set y prime equal to 0. Good start.
Do that.
Why not? So horizontal, the slope's going to be what? What's the slope in a horizontal line? 0. So y prime is just my slope, right?
Yeah.
So I have 0 equals x squared minus 2y over 2x minus y squared. All right. So how do we go about solving this? No, because x is not 0. Y prime is 0. And notice that I'm not saying y is 0 either. Yeah, so this basically ends up being 0 is going to equal to the top, right? All right. So what do I get next? Okay, so 2y equals x squared. Okay, so y equals x squared over 2. So you've never had this before. Every time we plugged in something to get a slope, we get an answer, right? We got a function. So if we look at this graph, if you look at the actual graph, is there more than one time where this is vertical or horizontal? Yeah, we got a horizontal line here, we got a horizontal line here. And if you look at the equation we just got, it intersects that graph at those 2 points. Okay, so we need to find, they said in the first quadrant, so they don't want the one at 0, 0. We need to be able to find that point right there. So we have an equation. And we have our original equation. To figure out where they cross, you used to be able to set things equal to each other. We're not going to be able to set these equal to each other because we don't have y equals. But we can use substitution. Okay, going back to that wonderful algebra. We're going to plug that into my original equation. And then now I only have is x, so I can solve for x. So I add x to the third, what's plus y to the third? 6xy, and y equals x squared over 2. So I have x to the third plus x to the x squared over 2 to the third equals 6x times x squared over 2. All right, solve for x. Let's see. So what's 16? It's 2 to the 4th. That's where the 4th third goes. This is one of those ones where, remember I said simplifying you don't necessarily have to do, but depending on what you need to use it for, it can help. So you could have left it as the cube root of 16 for the x, that'd been fine. We have to plug it back in to find y though. And y was divided by 2. So if you had the cube root of 16 squared divided by 2, you can simplify that because you will be able to cancel out that 2 on the bottom. Having it 2 to the 4 thirds allows you to see that. So, however, the bigger question is, were you able to get down to the point where you had 1/8 x to the third minus 2 equals 0? So you have to go back to remembering solving equations. These are just like a quadratic. Get everything to one side and factor things out. Once you got everything to one side, we could pull out the x to the third, and then we solve each piece. Okay?
Completely forgot that you multiply the block above it.
Oh,
Everything over 2, so I had literally the entire problem over 2.
Over 2.
Just, cube equals 4. That's really nice.
so yeah, you have to remember the distributing exponents, those little things. So all right, let's look at I want to do one before that one. I want to give you guys another one before I do a trick one. Actually, you know what? Let's do this one first. All right, find me the first derivative of this. I know it's asking for second derivative. We'll find the second derivative after you find the first derivative. Because remember, the second derivative is just the derivative of the first derivative. So if it's asking for the second derivative, you always have to find the first derivative first.
It's just something. And then
Yep.
over dx.
Mhm.
So we'll find that out. I'll try to get the bottom from it. And if it's keep over d.
Mhm.
Over d.
Yeah.
Where do I go from there?
Nowhere. That's where I wanted you to get to. Oh, you're fine.
Oh,
Otherwise, yeah. Not on that. Two. I'm sorry. Oh, Divide by this is fine, except that it doesn't go line right. The Y prime doesn't after the four X to the third, or full Y to the third. So you would have to solve that. Don't forget to do the derivatives. Right. And the Y prime is Y prime is full Y to the third. So four X to the third plus four Y to the third, Y prime equals. Then you have to solve. That's the yeah, one more time. Okay, that's all for my part.
Question, Professor. So then I took the derivative of that and said
You have to do the quotient.
the quotient. Okay, thank you. Thank you.
You're welcome. Okay. Common mistake, which I wasn't expecting. When you're doing the derivative, you have to do derivative of everything, including the 16. So what's the derivative of x to the fourth? 4x to the third. What's the derivative of y to the fourth? Y. Right. 4y to the third, y prime, or dy dx. What's the derivative of 16? 0. Okay. Don't forget to do that. Otherwise, this becomes messy. Also, this isn't equaling y prime. We have to solve for y prime now. Okay. I did see that in a few things too. The y prime comes after the y to the third because that's that chain rule. Because we don't know what y is. So we have to do the derivative of whatever y is. That's what y prime is. Now we have to solve this for y prime. So and then we divide by the 4y to the third. And we get negative x to the third over y to the third. And that's the first derivative.
You should put the Y to the first and always kind of treat it like it's variable.
Wait, repeat what you just said.
Like putting Y to the one. you should kind of-
That's not y to the 1.
Well,
It's y prime.
kind of treat it like it's its own variable.
Because it's in essence something we don't know. So yes, it's a variable in that situation. So, all right. Next, we want to find our second derivative. So I have y prime equals negative x to the third over y to the third. So how do I define the derivative of that? Yeah. Yes, I need to use the quotient rule. I have division here. You actually You could do this one of two ways. Yes. Yeah, that's actually what I was just going to say. Yeah, you could bring the y to the negative third up top and do the product rule for this. This one's not too bad to do that. It doesn't change the problem at all. It's just a personal preference. I'm going to do the quotient rule just because it's just going to be y to the sixth on the bottom anyway. It's not really going to make that big of a difference. So we need to do the derivative of the top and derivative of the bottom. So my numerator is x or negative x to the third. So what's the derivative of that? Negative 3x squared. My denominator is y to the third. What's the derivative of that? Almost 3y squared y prime. And what's the derivative of y prime? Just y double prime. So if you take the derivative of y prime, you get the second derivative, y double prime.
So do you add one instead of subtracting one?
They're not ones. They're primes.
Yeah.
I know they look like ones. They're not. Remember, you never write a 1 as an exponent, so you wouldn't see a 1 there anyway. Okay. You also could do that. Make it look more like an apostrophe. So if it's something that's going to confuse you, do that. All right. What's the quotient rule? So it's negative 3x squared times y to the third. So 3y squared y prime, negative x to the third, over the bottom squared. So I have negative 3x squared y to the third plus 3x to the third y squared y prime over y to the sixth. What's y prime? Right. So I'm going to take that and replace it because I know what that is. So that becomes negative x to the third, y to the third, instead of, do that right. So I have negative 3x squared y to the third plus 3x to the, negative 3x to the sixth over y to the sixth. Because the x to the third and the x to the third becomes x to the sixth. The y squared divided by y to the third becomes just divided by y. Or y to the negative first. What do you mean add them?
You add 2 to the third 3x cubed.
You're adding x to the third and x to the third to get x to the sixth.
Yeah.
Yeah. When you multiply, you add the exponents. When you divide, you subtract the exponents. So that's how I get y squared, y to the third is y to the, or divide by y, or y to the negative first. You cannot cancel out the y's. So, right. So you can leave that would be acceptable. This is another one of those ones where you can simplify this down more to get rid of the division on the top, and if you wanted to, depending on what you're going to use it for. But in this case, that actually is fine. So the only real difference when you're doing the second derivative of an implicit differentiation is you're going to end up with a first derivative still. Because when you take the derivative of y again, that's going to show up again. So you have to replace that with what the y would be in there.
Will that keep going if you do third?
If I did the third derivative, yeah. The nice thing is if I did the third derivative, I'm here. I'm only going to get y prime again. I'm not going to get a y second prime in the third derivative. So I don't have to worry about what the second derivative was to replace that. Does make my life a little easier. You're only ever going to have to use that one. But eventually the y's will end up, well, sometimes the y's will end up canceling themselves out, so you wouldn't have it there again anyway. All right, let's look at one with trig equations. Actually, you know what? I want to do a different problem. I want to do this one. Because this graph looks cool. That's what this graph makes. Huh?
What?
It doesn't.
Zoom out. I want to see what it looks like. Is it a fractal?
No.
Oh,
So, yeah, it does.
that's it. Oh,
It literally can't, like, because how tight the things get, it can't actually calculate out the stuff. But yeah,
what is this used to calculate? Art. Have you seen this? Some dude made a cyber trick. Out of a Desmos? Yeah. Just figuring out the equations. I really thought you were just gonna say a cyber trick.
hold on.
Who figured that?
Oh, this is just an equation. Like, it wasn't making figuring it out. Hold on, let me see if I can find. So one of my problems in my Calc 2 class, we do parametric equations. And you can do cool things like that with Desmos when you start looking at parametric equations.
How does he make it move?
You in Desmos you can have your variables change. So we got that one. Swirl flowers. That's the Eye of Doom. You know. So you can do some pretty crazy type graphs with Desmos. So that's in essence how they do like the Cybertruck and stuff like that. So, all right. So now that we
I mean, this is actually a computer program.
Yeah. All right, so now we're back to our ghost shape. So this is my equation. Let's do our derivative. So how do we go about doing it? All right, let's start simple. We have to do derivative of both sides, right? Okay. So let's start on that side. Let's do the derivative of this. So I've got sine xy. So I have to do the chain rule, correct? Okay. So what's the derivative of xy? Well, I have to do, this is a product, right? X times y is a product, correct? Okay. So what's the derivative of x? 1 times y. What's the derivative of y? Yeah, or we'll use y prime in this one. This is going to be more complicated. Times x. All right. Now what's the derivative of sine m? Cosine m. Okay, so the derivative of sine xy is cosine xy times y plus y prime x. So whenever you start to get these more complicated equations, all right, break them down and do them in pieces. Don't try to do it all at once. Okay? So we just looked at that one side. Don't forget you're only doing one piece. Very important fact. So we're dealing with the sine xy. We have the piece inside. That's a product. We do that product. We do the other piece. We do our chain rule. Okay, so do that in pieces so you can see it and then put it all together. This is where your colors can come into play so you know you haven't done it all. So I've done that piece. Now let's do the other piece. So I know this side is y, was it plus? Yeah. Plus xy prime times cosine xy. Now let's do this side. What's the derivative of sine x? Cosine x. What's the derivative of sine y?
Cosine y, y prime.
Yes. Just remember the y prime needs to go not inside the cosine. So I would put the y prime first. Because it's still the chain rule. So you're doing the derivative of the y, which is y prime, and then cosine y. You're in essence doing the chain rule for this one too. What's the derivative of x? 1. I don't have to put the 1 in front, but you're still doing it. Okay? You just don't have to write it because it's assumed that it's just an x. But if it was anything else, if it was x squared, I would have to have a 2x in front of it. That's where the y prime comes from. Because it's not just an x, it's not going to disappear. I have to put the y prime. All right. Now I've got to get my y primes by itself. So what's the next thing I got to do? What do you think we should do next? Move this one. You're gonna have to do that. I wouldn't do that first. The first thing I would do is I'd get rid of the parentheses by distributing. So I have y cosine xy plus xy prime cosine xy. Because when we start to move things around, if you move things around and you have multiplication and stuff mixed in, it'll get a little messier. Now that we've got everything in specific terms of addition and subtraction, I can move things a lot easier. So our goal is to do what? Remember back to the other problem where I had multiple y primes? Well, what did I say is the one thing this is going to come up often? What do we need to do? We need to get our y primes to one side and all the rest of the stuff to the other side. Okay? So let's move my y primes over here. So I've got xy prime cosine xy plus y prime cosine y equals, minus equals cosine x minus y cosine xy. Now that I've got my y primes on the same side, I can pull it out in front, right? And then I would divide. So the y prime is pulled out. What's left over? The x cosine xy minus that. So I have equals cosine x minus y cosine xy divided by x cosine xy minus cosine y. And that's my final answer. Yep, and then I divided by the stuff that was left over. Huh?
We just realized the whole problem really stuff.
Nope, no numbers. Just trig functions. They're just a lot of steps. Yes.
So why?
We used so when we did, hold on. I was here. We did the chain rule, and then the piece inside the XY, we had to use the product rule. So that's this. So these problems are just a lot of steps. There's a lot of places you can go wrong. Okay. Yeah, I don't.
Answer you when it comes to like messing up a step here and there. Like if you mess up a step, but all the rest of your problems, like
So It depends on what the step you messed up. All right, it really does. So let's take this problem for example. Like if you did all this correct and you put a plus, made them pluses instead of minuses. Not that big of a deal. A -1. That's a simple algebra mistake or a lapse in judgment or a lapse in concentration. I call them like those are simple little mistakes. If, for example, here you just put this as y prime and didn't do the product rule, that's a bigger mistake because that's a calculus mistake. That's a mistake that I'm making sure you understand in this process. So that would be more points taken off. All right. That's really the key. It really depends on what your mistake is. Is it a simple algebra mistake that you made that I'm really not testing you on, or is it a calculus mistake that I'm really testing you on? So those would be the things that I'd be looking for. All right. All right. Let's do one more problem. Let's see. What do I want to do? Let's do. No, let's not do that one. I'll be nice. Let me give you one that doesn't have a billion steps in it. I'll make sure you actually get the process. Let's do that one. All right, do this one. Yes, sir. Yeah.
Is why No, sir.
It's okay.
So this article. Evidence. Jesus is not a good triplets. So there's that y squared minus 2x y
I think so.
What?
I think so. Negative y squared.
minus 2xy y prime.
Yep.
Thank you. And now I just use that for all the
Yeah,
y primes.
But the product will the first set. What's the check first? You got that. And the other one's behind the product, you know, we're just like, okay. So remember we were talking about the differences in like errors, that one's a bigger error than everything I said. It's something wrong with your product. Oh, it's Blacksburg. So remember the conversation we were having? Yeah. That's why. Everything's right with the product, you forgot. Really, so if you just put the two there, that's three squared plus y squared. I was literally saying, yeah. Alright, so that one's easy, that one, to do y squared. The same thing as this one. X squared, that's what you do y squared. This piece here, you need to do the product. The derivative of x is not there. Other than that, that should be. And then you have y prime now. This drawing is to y. So you've got the prime. Yeah, oh, we're at the water prime. Yeah, you forgot to do the product one time. I think everyone's forget. Yeah, because it's multiplications, they have to do the, you have to do the first two parts. I'll be right on time. That's to y, not 24, right? That's fine. Okay, that's fine. It was like, it looked different than your other lines, and I wanted to. Yeah, okay. So really good.
So this is x is just 1, so just minus 2y times y one because it's a y. So it would be 2y times that for this one. For this middle term.
So the middle term is gonna be, no. The product rule isn't that. You kind of, wait. It's that. That's the middle term. There's no need to do a 2i.
Oh, so it's just,
It's just this.
and I keep, so that,
Yeah, that's the middle term. That's the derivative of that.
thank you.
Uh-huh.
Wonderful.
You're missing the product rule in the middle column.
Oh, I understood it.
Right.
That's what I got there.
So you have a y prime here.
Yeah.
Oh, wait, where's that 3 come from? It's y to the third. Actually, y. And when you do the y, even at that point, you should have
That's a
3
negative derivative.
y prime.
Yeah.
Well, you have that, that's fine. You actually have that. That's good.
How you feel better than crazy.
Well, she wrote the problem right. That was a mistake.
Yeah, there you go.
That was the one thing that changed.
I need a new.
But you- Okay, you kind of did your product rule, but then I don't see where that was like you did the product rule. This part's right,
Yeah.
but I don't see where that part came in here. There's 4 pieces here.
Okay. I think I took away.
I think you-
part and then placed it. Like this.
Yeah.
Okay.
All right. So lots of little mistakes. Some more bigger than more others. The one piece that, so when we're talking about like errors and like what would I consider worse than others? If for some reason you screwed up and put 3y, in all honesty, if you did the whole problem correct based on that, everything else is correct, that's a minor error. Okay? Because you just wrote something down wrong, but you showed me you could still do the entire process correctly. You understood the calculus and that type of stuff. That's a minor error. Forgetting that that's a product rule, that's a big error because that's a calculus error. Okay, see the difference? Are you starting to understand the difference in how I'm grading? Like those are the things. Yes, both errors. Yes, both answers would be wrong, but one shows me you know what you're doing, and one showed me that you still need work on certain things. So, all right. So let's go through and do this. So let's look at the one piece that's the product rule part. Let's look at that part first. Because there's 2 mistakes that could be made here that are bigger errors, and that there's that minus sign in front that's actually going to cause a lot of little issues. So I've got negative xy squared. So actually, I'm not going to do that as negative xy squared. So I've got xy squared. So what's the derivative of x? What's the derivative of y squared? 2y y prime. That's what you should have for the derivative of y squared. It's 2y plus the derivative of y. So this becomes 1y squared plus, 2y y prime times x. Because it's derivative of the second times the first, derivative of the first times the second. I'm going to put it all in the thing in a second. What's the derivative of x to the third? 3x squared minus this. So I have y squared plus 2xy y prime. What's the derivative of y to the third? 3y squared y prime. What's the derivative of 1? 0. Notice I put parentheses. You have to distribute the negative sign. Yes.
Would it be wrong to have the negative?
When you did the product,
Yeah.
if you did the negative x, that's fine, except you have to remember to put the negative sign there.
Well, the first one was
Right, because it's negative y. That's what I'm saying. So you have to remember those negative signs. If you don't, you're going to screw that up too. That's why I didn't do that, because it's more likely that you're going to forget that one. So that's where those negative signs can come into play. Yes. Oh, that doesn't matter. As long as you recognize that it's y prime and not something else, like it doesn't matter where you put it. It's just multiplication. Yeah. All right. So now we've got to clean things up a little bit. So I've got 3x squared minus y squared minus 2xy y prime plus 3y squared y prime equals 0. So let's move our stuff over and factor out the y prime. So on this side, I have y prime, negative 2xy plus 3y squared. And then I move the other stuff over. So negative 3x squared plus y squared. So y prime equals negative 3x squared plus y squared divided by negative 2xy plus 3y squared. All right. Questions with that? Okay. You know where your mistakes are. Most of it's algebra. Absolutely. There's a few, especially like looking for the product rule and looking for those things in there. That really comes up. Quotient rule is really easy to see. It's division. As soon as you see division, oh, I got to do the quotient rule. Product rule is a little harder to see. So just keep an eye out for that. So, but yeah, most of it is algebra. So, all right. Have a good night, class. After spring break, yes. Yeah. Wednesday. So yeah, so that's a good thing. So we have one more class. We have one class Wednesday. Next week is spring break, so we don't have class. When you come back, your review will be on Monday. Your test will be on Wednesday. So I might have the review test ready for Wednesday. I might not. If not, it'll be up on my website by the weekend, and you can just pull it off there to work on it. Okay, and then we'll go over it on the second, and then or the Monday, and then the test will be Wednesday. You're welcome.
Thank you, Professor.
You're welcome.